Video lecture chapter 5, radiation characteristics. X-ray beam quality, including voltage and kilovoltage, kilovoltage peak, density and kilovoltage peak, contrast and kilovoltage peak, exposure time and kilovoltage peak. Wavelength determines the energy and penetrating power of radiation. X-rays with shorter wavelength have more penetrating power. Quality is used to determine the mean energy or penetrating ability of the X-ray beam. This quality is converted by kilovoltage. Voltage and kilovoltage. Voltage is potential difference between two electrical charges. When the voltage is increased, the speed of electrons is increased. The electrons strike the target with greater force and energy. Voltage is measured in volts or kilovolts. Volt is a unit of measurement used to describe the potential that drives an electrical current through a circuit. A kilovolt equals 1,000 volts. Dental imaging requires the use of 65 to 100 kV. Less than 65 kV is inadequate penetration, and greater than 100 kV is overpenetration. Kilovoltage peak, or kVp, the maximum or peak voltage. This usually refers to the peak of voltage of an alternating current. A polychromatic X-ray beam is produced as a result of varying kilovoltage in the tube current. The quality or wavelength of the energy of the X-ray beam is controlled by the kilovolt peak. Density and kilovoltage. Density is the overall darkness or blackness of an image. When the kilovoltage is increased, the image will appear darker. When the kilovoltage is decreased, the image will appear lighter. Contrast in kilovoltage. Contrast is how sharply dark and light areas are differentiated on an image. A low kilovoltage peak setting, 65 to 70 kVp, creates a high contrast film, meaning there are many black and white areas and few shades of gray. Good for detection of caries. High kilovoltage peak setting, greater than 90 kVp, creates a low contrast image. Many shades of gray, good for detection of periodontal or periapical disease. Exposure time and kilovoltage. Exposure time. This is the interval of time during which X-rays are produced. It is measured by impulses, 1/160th of a second resulting from alternating current. An adjustment in exposure time is necessary when kilovoltage peak is increased. X-ray beam quantity, amperage and milliamperage, milliamperage seconds, density in milliamperage, exposure time in milliamperage. Amperage and milliamperage. Amperage determines the amount of electrons passing through a cathode filament. Increasing amperage results in an increased number of electrons traveling from the cathode to the anode and production of an increased number of X-rays. The quantity of X-rays produced is controlled by milliamperage. Amperage is a unit of measure used to describe the number of electrons or current flowing through the cathode filament. Amperage is 1/1000th of an amperage. In dental imaging, milliamperage ranges from 7 to 15 MA. Exceeding this produces excessive heat. Milliamperage regulates the temperature of the cathode filament. A higher milliamperage setting increases the temperature of the cathode filament. It increases the number of electrons produced and increases the number of X-rays emitted from the tube. MA is the production of milliamperage and exposure time. When milliamperage is increased, exposure time must be decreased to maintain constant density. An increased milliamperage increases the overall density of the image, resulting in a darker image. Exposure time and milliamperage. An inverse relationship. When milliamperage is increased, exposure time must be decreased. When milliamperage is decreased, exposure time must be increased. All dental X-ray machines have 3 exposure factor settings: kV, MA, and time. X-ray beam intensity, dependent on kilovoltage, milliamperage, exposure time, distance, inverse square law, and half-valve layer. X-ray beam intensity, the product of the quantity, number of X-ray photons, and quality, energy of each photon, per unit of area per unit of time of exposure. Kilovoltage regulates the penetrating power of the X-ray beam by controlling the speed of electrons traveling between the cathode and anode. Higher kilovoltage peak settings produce an X-ray beam with more energy and short wavelengths. Increase intensity of the X-ray beam. Milliamperage controls the penetrating power of the X-ray beam by controlling the number of electrons produced in the X-ray tube and the number of X-rays produced. Higher milliamperage settings produce an X-ray beam with more energy, increasing the intensity of the X-ray beam. Exposure time affects the number of X-rays produced. A longer exposure time produces more X-rays and a more intense X-ray beam. Distance. The distance traveled by the X-ray beam affects the intensity of the beam. 3 distances to consider: target surface, source to the patient's skin; target object, source to the patient's tooth; and target receptor, source to the receptor. As X-rays travel from their point of origin, they diverge and spread out to cover a larger surface area. The intensity of the beam lessens. Inverse square law. The intensity of radiation is inversely proportional to the square of the distance from the source of radiation. When the distance is doubled, the beam is 1/4 as intense. When the distance is half, the beam is 4 times more intense. Half-valve layer. Aluminum filters are placed in the path of the beam inside the dental X-ray tube head. The filters are used to remove the low energy, less penetrating, longer wavelength X-rays. Increases mean penetrating capability of the X-ray beam while reducing the intensity. The thickness of a specified material that reduces the intensity by half is termed the half-valve layer. This concludes our lecture.